We will be studying today Tichenko reaction. This is used for conversion of aldehydes to esters. So, suppose we are taking acetaldehyde, which is CH3CHO, that when treated with AlOR whole thrice will lead to the formation of ethyl acetate, which is your ester, which is CH3COO CH2CH3. Here, two molecules of acetaldehyde are used. Now, Tichenko reactions and Catalyzed reactions are almost very similar. Both are disproportionation reaction. However, there are some basic differences, like Cannizzaro reaction happens only with aldehydes that do not have alpha CH. Okay. Tichenko reaction can take place with aldehydes having alpha CH next to carbonyl. Okay. Point C. Cannizzaro reaction uses alkaline medium, whereas Tichenko uses neutral medium. Okay. Now the next reaction that we will study is called Aldol condensation reaction. We can divide it into three parts. One is intermolecular, B being cross, and C being intramolecular. Okay, so let us consider the first one. But before that, the reaction criteria is that it takes place with aldehyde take ketones that have alpha CH. Reaction can occur both in basic and acidic medium. Okay, let's take some examples for such reactions. So suppose I'm doing the intermolecular aldol condensation. Now, your aldols are called beta hydroxy aldehydes. Okay, so when aldehydes they condense and they form aldols, these aldols are known as beta hydroxy aldehydes. Now, the reaction mechanism step can be divided into four parts. One is the formation of carbanion, B, nucleophilic attack of enolate to another carbonyl, C, protonation step forming beta hydroxy carbonyl, D, elimination of water to form alpha comma beta unsaturated carbonyl. Okay. Now suppose I have given you acetaldehyde in presence of base. Okay, say this is dilute. Then two such molecules of this will combine to form this is your aldol, which undergoes elimination of water to form croton aldehyde. Okay, and obviously this is in presence of heat. Now, mechanistically, this is what happens. First, here all the reactions step are reversible. Okay, or I should say the reactions are reversible. Now suppose we have HCH2, this in presence of base, the proton will be abstracted, leading to formation of anion that will exist in resonance with the enolate. Okay, now the enolate formed over here will attack another molecule of acetaldehyde. Okay, and here it is worthwhile to mention that aldehydes react faster with enolates than ketones. Something we have already discussed before. And that would lead to the formation of what? O minus, double bond O, H, proton transfer, formation of beta hydroxy alcohol, aldehyde, sorry. Now this in presence of a base, the proton will be abstracted. Okay, which leads to the formation of anionic species. Okay, now forming a pi bond, this goes away. So here the mechanism that is operating is called E1CB, elimination unimolecular conjugate base, and that is how our alpha comma beta unsaturated aldehyde called croton aldehyde is formed. Okay. The reaction can also take place in acidic medium. So the mechanism for acidic medium is as follows. Acetaldehyde the lone pair will join with the proton. That means this will be formed, which we know the plus charge on oxygen is not stable. That means the pi bond will break. Okay. We can also think that a enol, which is also formed in an acidic medium, will now attack another molecule of this aldehyde. All right, and that is how we can think that a aldol will be formed. Okay. Now in presence of acidic medium and heat, this might get protonated. So that goes away. This how water is being eliminated, and we can think now protoaldehyde is formed. in this manner. It is interesting to note that we can represent, so this is basically what your E form. We can also write this in the Z form. But since in the Z form there is steric repulsion, so the Z geometrical isomer will be minor and the E form will be major. So a question relating to this can be asked or has been asked in the IITs before. Now let us consider acid catalyzed condensation of a ketone like acetone. Okay, so similarly we have a O, there's a proton which gets protonated, which can be now represented something like this. Attack from the enol can take place, which will lead to the formation of something like that. So we have now this. Joined to that. Okay. Alright. Okay. Some mistake is there. Just hold on. Something like this. And okay. And now this in presence of acid and heat obviously will get protonated to form that. Goes away, comes back. To give you alpha beta, alpha comma beta unsaturated ketone known as mesitile oxide. Okay, it is important to note over here that the mesitile oxide, which itself is also having another CH3 group next to the carbonyl, can further condense with another molecule of acetone in an acidic medium under influence of heat, leading to the formation of a compound something like this called as furon. Okay. Next. Now let us do some examples in which we will be using a much more simpler technique instead of doing all this mechanism to get the uh, alpha beta unsaturated aldehydes or ketones. Now, suppose I have given you the same molecule of acetaldehyde and I ask you to do a aldol condensation reaction followed by heat. Now, what you do in such a case is you write one of the acetaldehyde molecules like this and the other one in such a way that the alpha carbon is next to the OCO of the other molecule. So now you try to eliminate this water, and on doing so what we will be ending up with is something like this. Let us follow the same for acetone. Heat is necessary for elimination of water. If there is no heat, then beta hydroxy aldehyde or ketone will be your product in case of aliphatic compounds. Similarly, you have CH double bond O CH3. Again, you eliminate the water. And we get your methyl oxide. Whether you have got the product correct or not, just check next to the carbonyl, the double bond should be in alpha beta position. Alpha beta position. Let's try a few more. Say suppose I gave you something like that. Then obviously two molecules are over here used, that you have to keep in mind. Heat. So you have placed one such like that, another having its CH2, alpha position CH2 should be like that, next to the carbonyl minus H2O, and that would give you alpha, and this is again beta. Now I have given you cyclohexanone. Okay, what should you do in this case? Again use two molecules, that is your cyclohexanone, that is your hydrogen. Again you take out water, and the product you might get is something like that. Okay. To find out if your answer is correct or wrong, beta, alpha, beta. Alright, that is how you should be doing it. Giving you another one. So this is all about how much you can practice. These are your hydrogens. Again you take out water. That is how it should be done. Now, suppose I give you a alpha beta unsaturated aldehyde now, and I say find out starting materials. From what croton aldehyde is being made. So here, all you need to remember, this is applicable. What I'm teaching you is only for alpha beta unsaturated aldehydes and ketones. Okay, it means it cannot be used for something like this, which is basically a beta gamma unsaturated aldehyde or ketone. Not possible for this one. So all you do, heterolytic cleavage over here, disconnect this alpha beta bond. In the beta position, you put plus charge. In the alpha position, you put two negative charges. In the beta carbon, you need to add O2 minus to neutralize. Here you need to add H2 plus. So that means your answer here should be this, and for this one it should be CH double bond O. That is how it should be. Okay. Now, to find out how general is this process, let us try a few more examples. Suppose I gave you again alpha beta, you disconnect it, this becomes plus plus, that will be minus minus, that will be this, and this will be again adding H plus, and here you are adding O2 minus. Okay. Let me give you another one which is not perhaps something that we have done before. This is it. So again, this is alpha and this is beta. You disconnect. So this becomes CH plus plus and CHO. This is your minus minus. Obviously CH is there. From here you will be getting, after hydrogen, CH3CHO, and here you are adding O2 minus. So this is your benzaldehyde. Let's do crossed aldol condensation. So happens when two aldehydes of having alpha CH are used in same reaction container. So suppose I've given you acetaldehyde and a propanal. This is a molecule A, P. In the basic medium, enolate from here and here will be forming. So if the A combines with its enolate, okay, which means what? This combining with this. Or B can combine with enolate of B, which means what? Or you can think of the other possibility, A combining with the enolate of B, and what? B combining with the enolate of A. So this is B and this is A minus and this is A. This is your P minus. So technically we are getting 4 types of beta hydroxy aldehydes, 4 types of beta hydroxy aldehydes. Okay, so four possible products are found. 4 possible products are found. So this reaction is basically of no utility. It is just only for exam purpose, we are doing it, but for research, this is not very important, or for synthesis, this is not very good. Now, even nitroalkanes, which have acidic alpha CH, form carbanion to react with aldehyde and ketones. Okay. So suppose we have HCH2 something like that, and then this particular proton 2 can be taken up by hydroxide, leading to formation of a carbanion which can attack ketone or aldehydes. Okay. Something like that, undergoing proton exchange. Under heating conditions, will undergo elimination of water to form alpha beta unsaturated, nitrogens. Okay. Next. Claisen Smith condensation reaction. Now herein, when aromatic aldehydes react with aliphatic aldehydes, usually methyl ketones, or usually methyl ketones. These are called Claisen-Smith reaction. These are basically again cross-aldol type reactions. So we can think of AR, something like that, reacting with something like this. In presence of heat, it will undergo elimination of water to form something like that. Okay. Here, reactivity of this compound are increased by electron withdrawing groups. Okay. One thing should be noticed over here. If it is asked, give all possible products for this reaction, so one should be noting that AR C double bond OH, this may undergo Cannizzaro reaction. However, since it is slower, so minor amounts are formed, that is of AR C double bond O plus AR CH2 OH, slower than aldol, than cross aldol. So this can be one possibility, but very few amount is be formed. Another is obviously what we have done, that is Claisen-Smith product, or CH3CHO combining with CH3CHO, giving you the aldol product. Okay. So if at all the question is demanding all possible products, then according to me, this should be your answer. Okay. These are all the possibilities. Let's go for something called intramolecular aldol condensation reaction. Happens when the molecule has two carbonyl groups. It can be ketone ketone or aldehyde aldehyde or ketone aldehyde. Okay, so these are the possibilities. So I'm just taking one simple example for the sake of simplicity, easy one. Now I've given you this NaOH in presence of heat. So you see here you have a alpha CH and here you have a alpha CH. So either two hydrogens from here can be used to form a double bond with this carbon, or hydrogens from here can be used to form a double bond with this carbon. Okay. Now let us take both the possibilities. Okay. So let me first do the mechanism of this, then it becomes easier to understand how the product is forming. So suppose now if you take the proton from here, then obviously your inlet will look, or carbanion will look something like that. Another possibility is you can generate the carbanion here. So if the nucleophilic attack takes place from this to this carbon, okay, now try to number them 1, 2, 3, 4, and 5. So you're generating a 5-membered ring. Draw the 5-membered ring without thinking anything. This is your number 1, so this is number 2, this is 3, 4, this is your 5th, which is having O minus, right? Which is having O minus and a methyl group. Proton transfer. So this is your aldol type product, which obviously under heating conditions undergo elimination to give you the alpha beta unsaturated cyclic ketone. So this is my product. Now the other possibility being attack from here to here. Now if you do it, you see you are generating, this is 1, 2, 3, right? So now you're generating a 3-membered ring, and a 3-membered ring will be highly strained. Okay, a 3-membered ring will be highly strained. All right, this is highly strained. So not formed. Hence, this is not going for the reaction. Okay. Now let us take a few, 1 or 2 examples that can help us understand this. Suppose I've given you, say, all right. Now we know aldehydes are more reactive than ketones. Okay, so think of the enolates that can be formed over here. Okay, or carbanions. Now you have alpha position here, you have alpha CH here, you have alpha CH here. Okay, so let's do the, this is number 1, say this is 2 and this is 3, suppose. So if I have it something like that, Then I can obviously think of, by numbering I will get the idea of the ring. This is 1, 2, 3, 4, 5, and this is 6. Okay, so what I will do is, suppose this is my CH2. Now that can attack here. Obviously this will open up. Now 1, 2, 3, 4, 5, 6. I will make a 6-membered ring. Okay, this is my number 1 carbon. This is the O, that means this is my 6th. So 1, 2, 3, 4. This is 5. Sorry. 1, 2, 3, 4, 5, and this is 6. Now protonation will obviously give you this product, which if we do elimination of water via heat, the product will be something like that. Okay. Again, if I try to attack from here, this is 1, 2, 3, 4. Okay, so this is again going to give you not possible because highly strained ring. All right. Suppose I give you another problem, which is, say, you have done ozonolysis of this in presence of TMS. So basically we are doing reductive ozonolysis. Disconnect this bond, as I've taught you before. Look for your alpha carbon. So this is your, suppose alpha carbon, this is your alpha carbon, isn't it? Now from here you will be making a negative charge with the help of a base. Now this is going to attack here, that opens up. So if you try to number it, so this is 1, 2, 3, 4, 5. All right. Try to count from here again using 1 prime, 2 prime, 3 prime, 4 prime, 5 prime, 6 prime, and this is 7 prime. So basically now you will be having a 5-membered ring in one side and a 7-membered ring in the other side, where you have O minus. Okay, so I'm numbering it again for you. This is your 1, 2, 3, 4. That is your 5. And from the other side, we use a different color. This is 1 prime. This is 2 prime. This is 3 prime. 4, 5 prime, 6, and this is your 7 prime. Now what will happen? Protonation will take place. Protonation will take place. Under the influence of heat, minus H2O, water will go away. Alright, that's the answer. Okay. Now the next thing that we will be doing, suppose I have given you starting materials. Okay, how to find starting material. Suppose I've given you something like that. This is alpha beta unsaturated ketone. Yes. Disconnect it, and what I have taught you, alpha carbon will be having minus minus, beta carbon will be having plus plus. That means your answer will be, this will be adding O2 minus, this will be adding H plus. Okay, so that is your answer, as simple as that. Okay. Try doing the same thing for this one also. This is alpha, this is beta, and you see you will be getting back this compound. Okay, so these are easy ways in which you can utilize these in GE mains and advanced examination to, like, in a small time you can do a lot of things. Now the next reaction we'll be doing is called Claisen reaction, but not in this video. It is already around 51 minutes, so we'll be doing this in the next one. Okay, thank you.